I'm going to do it in the table. No, I'm not. I don't know what I'm going to do. It's going to box the whole question. This board. Okay, LS, RS, tan X. I'm doing this way because I'm lazy and I see tan X as one of two steps. Leave it, or it's sine over cos. I don't have to write it down each time. But that's just me. So I'm going to have 1 minus something. I know that. And then here I'm going to have 2 sine x cos x. Do you see how I put that in brackets? Because I know I'm replacing it with one of the 3 coses. This is my educated way of guessing which cos I should pick. In the end, I need tan x. In the end, I need sine x over cos x. Okay? I can see that I need this baby to stay, and I need these to get out of my life. Right? That's what I see. I see the 2 sine x needs to get out of here. I just want to keep the cos. And then the rest I want nothing of which is in the top to be there. So I want that 1 to get out of my life as well. So I go to look at my formulas over here, and I say, okay, I got 3. I have cos squared x minus sine squared x, which I could put in. If I put that in, I'm going to have to go to the Pythagorean theorem identity and replace it some more. So that doesn't sound like a good option. Okay? Then I have 2 other options. I have the 2 cos squared theta minus 1, and the 1 minus 2 sine squared. If I put the 2 cos squared x minus 1 in there, I'm going to negate the negative 1, and it's going to become a plus 1. And then I'm going to have 1 plus 1, which is 2. Is that any better? No. So I see that I might want to try this one, the 1 minus 2 sine squared x. Because I got to get rid of a 2 sine x, right? I need to get the 1 to get out of my life. If I pick this one, I'm going to go negative 1 minus 1, which is a plus 1, not helpful. So this one looks like the one that might help me get to where I need to be. So you're going to make educated guesses on the cos 2x by saying, what do I need to keep? What do I need to get out of here? How could it help me? So the one that I'm going to pick is the third one, which is 1 minus 2 sine squared x. And this is why I put it in brackets. Because if there's a binomial that falls behind a minus sign, that negative sign has to go to both, right? So I'm actually going to get 1 minus 1 plus 2 sine squared x over 2 sine x cos x. Those cancel. The 2 and the 2 cancel. The sine and the squared cancel, only because this is multiplied up here and this is all multiplied up here. If I had like a 1 still attached to this, I wouldn't be able to cross off, right? If I had like 1 plus 2 sine squared, I couldn't cancel. But because all I have left is a multiplication and a multiplication, I can cancel. And so then I'm left with sine x over cos x. And then the toddler could look at the image and say they match, so I could say LS equals RS. And the LS equals RS is 0.5 of a point, just so you know, until you don't remember it. You're out 0.5. And if it's at a 2, that's a large amount to be out. Because the written response is marked on increments of 0.5s. So your one part of your written response is going to be worth 2, the other one's going to be worth 3, and there's 3 written response. So 5, 5, and 5, 15. Okay? All right. Try this one out. So, for this one, it's very similar to the one we just did. We have LS, RS. Then we have sine 2x over cos 2x plus 1. Do you see how sometimes it's really hard to not write the first step back over when you just start working at it because you just feel like, hey, I'm going to start working? You have to write that first step. Check again, make sure that everyone is writing that first step. I'm being crazy about it because it just makes you immediately not get any marks, which is sad. So sine 2x is 2 sine x cos x. This one is sine x over cos x. So I know I need, when I look at the top here, I need the 2 cos x to go away. So I'm probably going to need the formula that has 2 cos x, which is the second 2 cos squared x minus 1. Minus 1 plus 1. Those cancel. Then I'm left with 2 sine x cos x over 2 cos x, cos squared x. This cancels this cancels this. And I get sine x over cos x. And now a toddler could say the images match. And I get left side equals right side. Okay? Then we're flipping over. Okay. This one I specifically picked because we just kind of talked about this on the previous page, right? These are all sines and coses. There's not actually anything I can do to them, correct? So this is where I told you maybe spot that one of them could be multiplied by a conjugate to get the other one, right? The catch here is don't do both sides. Pick one and multiply by the conjugate. If you pick both and multiply by the conjugate, you're kind of undoing what you did. So I'm going to do this one in the other method. So I have 1 minus cos x over sine x equals sine x over 1 plus cos x. I'm going to pick this side because it's easier to write on. This will get squishy. So I'm going to multiply this one by 1 minus cos x. And I have to do it to the top. Now, this is something you're going to learn in limits. Watch me. Watch me. You distribute the conjugates. You never distribute the ones that aren't. And in limits, we're going to do the same thing in calculus. You distribute the conjugates. You do not distribute the ones that aren't. Now, why? Why is that? I want to keep 1 minus cos x. Do you see that? I want to keep 1 minus cos x. What do I want to get away? I want the sine x to get out of my life, correct? If you take that sine x and you start distributing it into that bracket, what's happening? The only way you're going to get it to go away is to take it back out. So just don't put it in. So this is the rule, and I would write it there. I would write it right beside. When you're multiplying by conjugates, multiply the conjugates together, FOIL them, distribute them, do a binomial distribution, but do not distribute the other two. Because remember, we're always trying to get the left side to equal the right side. And this right side has a 1 minus cos, and so does this one already now. And I want them to stay, and I want that sine x to go away. So I'm just going to rewrite this side. This is why I do the chart, because I'm lazy and I don't want to rewrite that side. And then I'm going to rewrite the top without putting them together. And it's hard to not put them together because you're so used to seeing a bracket and distributing it in. So you have to stop yourself. And it's good practice because when limits comes, we're going to do the same thing. For limits, we want to get the denominator to go away. So if we distribute the denominator in, we can't cross it off. So it's the same rule for limits. So it's good to get practice with it. And then we're going to distribute our bottom. We get 1 times 1, which is 1. I'll show the steps, but you don't have to. Plus cos x. You don't have to show the middle one. Minus cos x. Minus cos squared x. So these are going to cancel. So I'm going to get 1 minus cos x over sine x. You want to know another thing that happens in proofs that goes wrong? You guys drop the x's off, or you drop the thetas off, and you just have sins and cosing all over the place. Okay? Remember, it's not cosine unless it has an x. It's not sine unless it has an x. It's sin. And here we have sine x times 1 minus cos x. And 1 minus cos squared x can be replaced with sine squared x. Those cancel. And now some people will say left side equals right side. Remember, a toddler has to look at this and say, those look the same. No toddler is saying those look the same. They're not going to be like, oh, I understand that they're canceling them off, and therefore that. No toddler can do that. Okay? So we're going to get 1 minus cos x over sine x equals 1 minus cos x over sine x. And now we can write left side equals right side. So that's one thing people forget, that you can multiply by conjugates. The most forgotten situation that happens in proofs is forgetting that you can take out GCFs for one step, or two, not spotting that you can factor something. So sometimes it's like 2 sine squared x minus 3 sine x plus 1. That can be factored, right? Like, or that you have a difference of squares and people don't realize you can make it expanded out. Like if you have sine squared x minus 1, you can also write that, instead of cos squared, you could write that as sine x plus 1 sine x minus 1. So you're trying to make sides match, right? So if there's no definitive like sine, or 1 minus sine squared x is cos squared x. It could be better used as 1 minus sine x, 1 plus sine x, depending on what the other side looks like. Okay? Example 6, I'm going to get you to try on your own. I'm going to give you a hint of what I would do first, is I am going to take that secant out of the top. I'm going to GCF a secant x out. And then I'm going to have secant x bracket 1 minus sine x. Okay? Take a secant x out. Try that one out. Let me do the chart. Do you see how it doesn't matter which method you use, but it does matter that you have the right steps that you're doing? So left side has to equal right when there's an equal sign. We have to start off with LSRS and a chart. If we're doing the chart, there is methods to both that have to happen. Both of them most definitely have to start off with the first steps being rewriting the question. Like, I can't start taking a secant x out. You know how easy it is to go secant x bracket 1 minus sine x right now? You know how wrong that is? Very wrong. So stop yourself and write out the very first question first, okay? So secant x minus sine x secant x. It's hard for me. I sometimes want to just write my first step, but I have to stop myself. Okay, to me, the right-hand side looks more complicated, so that's what I'm going to work with. I'm going to take a secant x out, and I'm left with 1 minus sine x. Please remember to write the 1. When you take a secant out of secant, you're left with a 1. It doesn't just go away. And you should be able to double check when you GCF, because if you distributed it back, would you get what you had? So after you take out a GCF, I always double check my GCF. So I took a secant x out, and I try to distribute, see if I get it back. Secant x times 1 is secant x. Secant x times negative sine x is negative sine x secant x. I feel good about my GCFing because I got back what I had, if I would put it back in. So always double check your GCFs. You'll catch the ones that you miss if you do it that way. Because if I got rid of the 1, I'd be like, okay, I get negative sine x secant x, and then I'd be like, ruh-roh, I'm not getting back what I had. Okay? Over cos x. Now, I'm going to go secant x is 1 over cos x. Immediately, I am getting a fraction in my numerator, so I'm going to write my numerator in brackets. So I get 1 minus cos x times 1 minus sine x over 1 divided by cos x over 1. This isn't a full fraction yet, so I'm going to get 1 minus sine x all over cos x, because numerator times numerator, denominator times denominator when you multiply fractions. Now it's a full fraction and a full fraction, so I can flip it. So now on this side, I have 1 minus sine x over cos squared x. Can I multiply by the conjugate now? Yeah, but I've ran out of room, so I'm going to start working on the left-hand side. It doesn't matter. You could have just worked the whole right-hand side, but I'm like, I'm going to start, let's see what I can do to the left. So I know the only thing I can do to the left is multiply by the conjugate. So I'm going to go 1 minus sine x. I distribute the conjugates. I don't distribute the top. It happens to be a 1, so it wouldn't matter. I'm going to get 1 minus sine x on the top. I'm going to get, please don't go from this to cos squared. Please don't do that. Please show the middle step at the very least. 1 times 1 is 1. Minus sine x plus sine x. You wouldn't have to show that if you didn't want to. Minus sine squared x. And then I get 1 minus sine x over cos squared x. And they match. And if that wasn't fun enough, example 7 is more. Try it out. So we have the cos 2x in the top. There are three options we can choose. There is the cos squared x minus sine squared x and cos x. That just sounds like a whole lot of coses and sines mixed up, so I'm not picking that one. And then we have 2 cos squared x minus 1. And then we have 1 minus 2 sine squared x. If we pick 1 minus 2 sine squared x, we have sines and coses mixed again. Yeah.
Why is sine squared x on the denominator on the left side?
Oh, it should be a sine x. I have no idea why that's a square. I'll go fix that in a second. Good catch. So I would replace it with 2 cos squared x minus 1 just so that they're all the same. My board is not going to like this. Okay. So I'm going to leave this one sit for a little bit. This one over here, the top is 2 cos squared x minus cos x minus 1 over, and I can take a sine x out of this one. And I get 2 cos x plus 1. This over here, this 2 cos squared x minus cos x minus 1, I know that the 2 cos x plus 1 on the bottom I need to get lost, right? Because I want to keep the sine x when I get the rest gone. The 2 cos squared x minus cos x minus 1 I can factor. So remember, if you're stuck, sometimes you're missing factors. Or GCFs often. So if I go over here, I can factor this as 2m squared, let m equal cos x. 2m squared minus m minus 1, 2m squared minus 2m plus 1m minus 1. Group. Take out a 2m. I'm left with m minus 1, a plus 1, I'm left with m minus 1. And so I get m minus 1 and 2m plus 1. Which is cos x minus 1 and 2 cos x plus 1. Which is really nice to see because I need it to cancel off, right? So on the top, I'm going to get cos x minus 1 times 2 cos x plus 1. Over sine x 2 cos x plus 1. Those cancel. Now, I did it this way. Could you have multiplied by cos x plus 1 on this side and worked your way to get to that side and work that one down? Sure. I just think it's faster, but you could have done it differently. Proofs are proofs, right? So if you did it differently, not a problem. If you want to ask me if you think it's right, or if I think it's right, I can. Okay? And we have example 8 and example 9 to try. I'll bring 7 back just so if someone wants to write it again, they can. All right. So the left-hand side, I see the 2 sine 2x, and I immediately know I can replace that with 2 sine x cos x because there is only one formula for that. So it drew me to it. The bottom, 4 sine squared x minus 1, is often what gets left the longest and people get stuck, but that's a difference of squares. So the square root of 4 sine squared is 2 sine x. So that would go in the front of each bracket. The square root of 1 is 1, so that goes to the back of each bracket, and then plus and minus. And then I can see in the top that I can take a cos x out. And I'm left with 2 sine x minus 1 over 2 sine x plus 1, 2 sine x minus 1. And so I get, a lot of movement. So I get cos x over 2 sine x plus 1. Now I feel like I'm tapped out on this side. And my bottoms match. So that feels like I'm something productive. I have the denominators matching. The top right, I can take out a cos x. When I do that, I'm left with sine squared x plus cos squared x over 2 sine x plus 1. Sine squared x plus cos squared x is 1, and I know I need it to go away, which it does. It comes to 1. So then I have cos x. And I have to show this step, because they do not look the same until I show this step. So then I got left side equal right sides. And this one, I have cos x plus cos x tan squared x. And then I have secant x. The left side looks more complicated, so that's what I'm going to deal with. I'm going to take out a cos x. And I'm left with 1 plus tan squared x. What is 1 plus tan squared x? Secant squared x, yeah. So you have to remember that it's on the formula sheet. If not, you might change tan squared x to sine squared x over cos squared x, make the common denominators a whole bunch of work. But if you know 1 plus tan squared x is just secant squared x, I can turn secant squared x into 1 over cos squared x. This cancels this off, and then I'm left with 1 over cos x, which is secant x. I could have changed secant to 1 over cos and made them both be 1 over cos x, still equaling, still same image, right? Left side equals right side. So I posted a massive assignment. It's massive. Like, saying it's massive is an understatement. It's massive. The first question on it is verifications. It says it's due next Tuesday at midnight. I just put it there so that it actually holds itself in your stream. It's not due, but it's just so that you don't, you remember you have it. You have all this access to it. So it's not actually due, but it'll hold itself in, you know how like when something is due, it sits there and it tells you it's due. That's the reason why I wanted to sit on your front page and tell you that. But in the actual assignment itself, there's the questions, and then there's, oh, the trig review answers are from. One second. Good thing I got them on there. The trig review answers were the trig review answers to your hand. Took them out though, so don't worry. So, the trig to review questions. So the first, it's A to D are verifications. Then I have A all the way to U as proofs. So if you're like, I just don't have enough to do. A to U, proof, plus you have the textbook if you need. And then I have A to H in solving. And then for 4, I have A to D in NPVs. So practicing those restrictions, right? So the only thing that's not on here that is in the curriculum, which is why I waited till this, is the sum and difference. So we're going to do word problems tomorrow, going over like Ferris wheels, pendulums, things that can actually, I could have a wheel with a bucket on it, it's picking water up below the ground and it's dropping water above. Has to be circular, pendulum-like, has to be a max min that's consistent. We're going to do word problems on that tomorrow. And then on Thursday, we're going to do sum and difference, and then we're done. All of trig is done. All we have left is logs and exponentials, which is 1 unit. And then radicals, rationals, and other functions. Sounds like 3 units, but it's 7 lessons total. Radicals has 2 lessons, rationals has 2 lessons, other functions has 3. Okay? So we will be done early and start with some calculus. We're going to do calculus and review. Calculus and review. Calculus and review. Calculus and review. Okay? Because you guys come back January 9th. Come back really late.